Lesson 8.3 is again related, I don't know why I keep saying that, related rates. Using one formula, they're going to be circles or spheres. Number 1 says the area of a circle is increasing at a constant rate of 352 square feet per second. At the instant when the radius of the circle is 9 feet, what is the rate of change of the radius? Round your answer to 3 decimal places. Okay, draw a picture if you want. It may not help you, but we've got the area is changing at a rate. So that's a dA to dt. Area to time is changing at just a constant rate of 352 square feet per second. So it did not tell me what the area was. At the instant when the radius, so remember radius is just halfway through the circle, is 9 feet. So that's going to be important. What is the rate of change of the radius? So we want to know dr to dt as our final answer. So I've got to have a formula that connects all of this together. And that would be using area of a circle, which is pi times radius squared. I have to differentiate this with respect to time. So I'd get dA over dt equals, remember pi is just a constant. So I'm going to have 2 pi r, but then times dr over dt. So what I'm trying to find is this. That means I have to have something to plug in for everything else. Okay? And so I've got that. My radius at this time is 9. Okay, and then I've got my area is changing with respect to time of 352 square feet per second. And so I've got everything I need. So I'm going to just divide by 2 pi 9 or 18 pi. I like to put parentheses around it so it knows I'm dividing by that whole thing. And it said to 3 decimal places. So the radius to time is changing at 6.22 feet per second. All right, number 2, the radius of a sphere, I'm not going to try to draw that, but you know that's like a ball, is decreasing at a constant rate of 5 centimeters per minute. At the instant when the volume of the sphere is 1,611 cubic centimeters, what is the rate of change of the volume? And they're nice and always give us the formula for volume of a sphere. Okay, so let's pick apart what we know. The radius is decreasing at a rate. So it's not, the radius is 5, it's a rate, so dr to dt. Radius to time is decreasing at 5 centimeters per minute. At the instant when the volume is 1,611, so that's not how the volume is changing, that's simply the volume. What is the rate of change of the volume? So our end goal is to solve for dV to dt. And they're giving us the formula that volume is 4/3 times pi times r cubed. So I would just start and think, okay, well, I know I've got to take the derivative of this formula with respect to time, and then I'll figure out what I have and what I still need. That would get dV over dt equals, so remember 4/3 pi, that's all a constant, so take times 3, the 3's would cancel, that's 4 pi r squared times dr to dt. Okay, do I have a dV to dt? No. That's what I'm trying to find. Do I have a radius? I have how dr is changing to time, that's going to go here, but I don't have a radius. So I'm going to have to use this formula because they told me the volume at the instant they want is specifically 1,611 cubic centimeters. equals 4/3 times pi times r cubed. I can actually use this to solve for what the radius is when the volume is at that instant. Okay, so I'm going to, I don't know, I guess times 3/4 first to get rid of this. Which should be 3 times 1611 divided by 4 gives me that. I'm going to divide by pi. Gives me that, and then I'm going to cube root it. Because that's the opposite of cubing something. And then that button, if you go to math, it should be option 4. I'm going to plug in that answer, and that gets me about 7.272-ish. So that gets plugged in. Squared, and then my rate of my radius changing to time was -5. Okay, so then we're going to take 4 pi times 7.272 squared. Probably should have kept that decimal in there, but I didn't think about it. Times -5. And so that's -3,322.673 cubic centimeters per minute. Is what the volume is losing.